All right, we're going to talk about timing diagrams and how the timing diagrams will go to the line ladder, but first we'll start with our specification document of what we want to do. Simple process. Got motor 1 will start immediately when the start button input is closed, and it will stop immediately when the stop input is closed. Normal start-stop station. Nothing unusual about that. And after 10 seconds after motor 1 starts, output 1 will energize for 10 seconds. Just energize for 10 seconds and then turn off. Right? And output 2 will energize for 10 seconds after motor 1 stops. So you could use output 2, something like a brake. When the motor stops, it turns on for 10 seconds to energize a brake coil. Okay? That's it. Very simple specification, but we start with something written. We start with something written, like in all your labs and everything. You know what's expected of you. You don't have to add anything more. You don't subtract anything. You get what's on here, and that's it. It's very clear as to what we need to do. If you start working without a specification, it's anybody's guess as to what you're going to accomplish. Okay? Additionally, like in the labs, we have which inputs will be used and everything else. I've left that off of this for just clarity, and you'll see that when we get to the program. But in the specification document you guys get for the labs, you've got inputs specified, which pins and outputs, what's connected to each one, so that it's very specific as to what you have to code. So when you're doing the timing diagram, you want to make sure that you have all of your inputs on the timing diagram, all of your outputs on the timing diagram, and any memory coil you might need to accomplish that. So our inputs, start, stop, OL. Our outputs, motor 1, output 2, output 3. And then the memory coils we're going to use for the timers to indicate the timers are either done or not done, or T1 on, T2 on, and T3 on. We'll have 2 on delay timers and 1 off delay timer. So we come over here and we hit the start, and pushing the start will cause motor 1 to turn on immediately. And it will stay on until we hit the stop. I put little green arrows on here to show you the relationship on which edges cause which action. So this start here will cause that action of turning on. This action of turning on will cause that to turn on. This action of turning on will start this delay process. This delay completing and that coil turning on will start the next delay process and come on out there, and then that'll turn on. You notice I do not have the delay set up over here. Okay? So this output, this delay will start when that output turns on. There's a lot of things in, well, why don't I just have a 10-second delay here and a 20-second delay here? If those things are supposed to be independent of each other, if I change this to, say, 15 seconds, that will push it over here, and I'll lose my 10-second difference in there. You'll have to sit there and make sure you adjust all the numbers. It's easier to have this triggering that, so this becomes independent of each other. Now back over here, I hit the stop button. That causes motor 1 to turn off. Motor 1 turning off results in this turning off because of it controlling the timer, and also down to here. And that turning off then triggers the delay to start. So here's our delay that takes place in here. Now if we look at our output 1, the specification said 10 seconds after motor 1 turns on, we get a 10-second pulse. So here's that 10-second delay. And then after that 10-second delay, this pulse turns on. During that delay period, that output 1 is on. When we turn everything off, we start our delay period here where this off delay is still on, but motor 1 is off. Right? Look at motor 1, it's off, but that output is still on. The combination of those two will make this output here. So drawing the timing diagram, you can draw all that out and you say, okay, well now I can see how it operates, but how do you implement that in the PLC in the code. If we look at this output here, this is on when this delay, this output here is off, and this output here is on. So if you come straight down there, you see that's on, that's off, so that should be on. You guys follow me on that?
Yep.
Okay. Now over here, motor 1 is off. This off delay is still on, so that means that output on. So you look at something, if a coil or an input is off, that goes to a normally closed contact, because the input's not being energized. Normally closed contacts are closed, so it allows power flow through them. If the coil is on, like this one over here, you'll use a normally open contact, so when this is energized, those contacts are closed and allow power flow to go through. Okay, so combinations, series combinations of normally open and normally closed contacts, you can come up with all kinds of timing combinations to meet what we have here. You guys have any questions so far? We're doing okay? All right, let's look at the line ladder that I have here. I've got the start, stop, holding contacts for motor 1, OLO contacts for motor 1. Again, that's a simple start-stop station. Okay? Nothing fancy on that. Now if you remember on the timing diagram, motor 1 controls timer 1, right? So if I come over here, motor 1, that closes, that starts timer 1. It's an on-delay timer. The output doesn't start immediately, does it? Okay? So we've got 100 for tense timer, so 10 seconds later that coil will energize. Now that coil, T1 on, controls the second timer. Okay? 10 seconds later, 10 seconds after those contacts close, this output will turn on. Okay? So if I look at this and I say, wait a minute, 10 seconds after the motor starts, there's got to be a dead time. That's the first delay. The next 10 seconds is my output on. That's the second delay. And then when that second delay expires, that output will go on and turn off everything. So if we look down over here, T1 on contacts will be closed at the end of the first delay. T2 contacts will open up at the end of the second delay. So in the meantime, between the first and the end of the second delay, both of those will be closed, provide us power to output number 1. Okay? Now if we look down here, we've got motor 1 and T3 on. So if I look at this, motor 1 is running, stop motor 1, those contacts close again, right? As soon as motor 1 starts running, those contacts close, turn that on. That output goes on immediately because it's an off delay. So those contacts will close. But motor 1 is running, so those contacts are open, aren't they? So there's no power flow through there. We come down there, stop motor 1, contacts closed. These will stay closed because it's an off delay. So we got power flow through here, and output 2 will go on for 10 seconds after motor 1 stops. Okay, we have the program set up here. We're in the off condition right now. You see we have power flow through OL and stop. We're waiting for everything to start up. Our timers are reset. We've got our off delay timer waiting. We're in the off condition right now. T1 on is off, T2 on is off, so everything is set up here, ready to go. Motor is off, but since we're in the off condition, our off delay timer is not energized or anything, so everything is off. Okay. Come over here, hit the start. Motor 1 is on, we're stopped timing through the second. This is the first delay period. Nothing is happening out here on our outputs yet except for motor 1. Okay? T1 on is, there we go. Now so our output 1 is on during this second delay period. We're almost ready for this to turn on. There we go, it turned off. And there we go, it's off now. Does So everything's primed right now for us to turn off. We went through our startup sequence. You see T3 is on, and it will stay on when we turn off motor 1. So when motor 1 turns off, that will stay on. This will allow power flow through it, and our output 2 will happen. So I come over here, hit the stop button. There we go, motor's off. The timer is still on because it's an off delay timer. Both of those allow power flow to turn on our output 2 or brake or whatever it is that's happening for 10 seconds after the motor shuts off. Then we're done. Very simple. Watch that again. There, start it up. We're in timing period number 1. There we go, timing period number 2, which our output number 1 is on. Almost there, okay. That's done, so it turns the output off. And now we're running. Everything's running. I hit the stop button. And there we go, there's our output. So push the start. The motor 1 is running. We're in our first delay period. We're up to 50 seconds in it. Okay, 90. There we go. There's our output number 1. It's on. So we're in the second delay period now for that to be on. 70, 90, and then it's off. Now we're running. Hit the stop button. Motor stops. Output number 2 comes on. It'll be on for 10 seconds. We're good to go. Okay. All right, lab number 6, you've got the condition where your motor 1 and motor 2, 3, 4, 5, 6. And let me go ahead and put motor 3 on here. And you've got the delay associated with that. So in your specification, when motor 1 is starting, or when any motor is starting, if it is stopped, for instance, if motor 1 is stopped anywhere during this delay period before motor 2 turns on, it has to stop immediately. Right? So motor 2 is on, and anywhere in this delay period, if I stop motor 2, it stops immediately, and then the next one starts the countdown delay for motor 1, and then motor 1 will shut off after that. Right? And so the big question we get is, what do we use to control the off delay timers? If I'm looking at this and I'm saying, wait a minute, motor 2 is controlling the off delay for motor 1, right? Motor 3 is controlling the off delay for motor 2. And if you do not enable that off delay timer for the, if I do not enable motor 2 off delay until motor 3 comes on, it'll sit there and shut down immediately if I stop it anywhere during this delay period. And the key is what you use to enable the timers. On the turn-on cycle, where we're going on, it's easy to use the timers to turn each successive motor on. Okay? Timer 1 times out, turn on motor 2. Timer 2 turns out, turns on motor number 3. And the timers can each trigger each other. But if you use the timers for the reverse process, they'll all the motors will turn on all at the same time. And you're going to have a problem. And the key is to look at that. And looking at the specification, motor N is running, and it's stopped before M plus 1 starts running. Motor N stops immediately. And N, you can replace that with 1 through 6. So again, if motor 2 is running, but motor 3 has not started yet, and I hit the stop button, motor 2 stops immediately, and then the delay starts to shut down motor number 1. And if I look at that, and if I use the off delay for motor 2 controlled by motor 3, it'll provide that, because that off delay is not turned on until motor 3 starts up. Motor 2 off delay is not enabled until motor 3 starts. Does that make sense to you guys? I mean, that's the big key to making the shutdown process work, is enabling the off delay for motor number 2 by motor 3. Off delay for motor 3 by motor 4. Now, is there an off delay for motor 6? No, if they're all running and we hit the off, motor 6 stops immediately, right? So there is no off delay for motor 6. Bam, it stops immediately. But then since motor 6 is running, the off delay for 5 is enabled and it will start counting down. And then motor 4 counts down. Motor 3 counts down. Okay? No questions? You guys are wonderful, huh? Oh, the delay. You guys asked me about the delay, right?
Yeah.
Okay. Think about this delay. You've got, let's draw with these 3 motors here, okay? I'm going to put these up here. All right, we're going to stop. This will stop. And that'll stop, right? Down here. Okay? So I've got my delay here. I've got my delay here. And everything is on. Okay? So let's look at this. I got to go a little wider so you can see the whole thing. Okay? And let me draw these lines out here the rest of the way so we can see them. Okay. If I only have a 3-motor system, if motor 1 is on and motor 3 is not on, are we in a delay? If motor 1 is on and motor 3 is not on, are we in a startup delay? Yeah. If I've got on, we're not in a delay anymore, are we? Now when I shut back down, first one to shut off is motor 3. But is motor 1 still running? Okay? So if motor 1 is on and motor 3 is off, we must be in a delay also, in the off delay, right? So if I need to know if I'm in a startup or shutdown delay, all I need to do is look at the first motor and the last motor. If the first motor is on and the last motor is off, we're either in a startup or a shutdown delay. And you can do that with 2 contacts. I've gotten the delay period where people look at it and they put, if it's motor 1, motor 2, it's huge number of rungs with huge number of contacts. That whole thing can be simplified down to 2 contacts. Okay? I mean, it's in this case here, we'd have motor 1, here we go. If motor 1 is on, motor 3 is off, that must mean we're in a delay period.
We're using motor 3 as like motor 6, right?
I'm just using an example instead of putting all 6 motors up here.
Right,
Yes.
motor 3 being the last one.
Right. And so motor 1 is on, and the last one here is motor 3, so I put that here. So the first one to shut off is going to be motor 3. Those contacts will close. Motor 1 will still be on, right? And so that tells us we're in a delay period.